Now we are going to study ray optics by using ray box. Now we have taken a glass slab. This is a beam. The beam is along the normal. So when it is along normal, that time the light is going straight. When we tilt the glass slab, then the light bends towards normal. The original path was this, but due to glass slab, when it entered from rarer to denser, then it became like this. It has gone towards normal. And when it had to go out, when it was going out of the glass slab, it means that denser to rarer. Then it bent away from normal. This was its original path. So incident ray and emergent ray are parallel. The bending done by first interface is equal and opposite to bending done by second interface. So they are parallel. The ray is just displaced. So now we are seeing a prism. In a prism we can see that the incident ray is entering the slab, entering the prism, and when it enters it bends towards base. So this is its normal. It is bending towards normal. While going out, it is bending away from normal. But it is bending towards base due to its shape. This is the base. In first interface also it has bent towards base. In the second interface also it has bent towards base. So we can see that both are doing the same job. So we are getting net deviation. But in a glass slab we can't get that deviation. So now we are going to observe prism in white light. That how the different colors get separated. Here you can see that the colors are getting separated. On top there is red and on bottom there is violet. Red gets bent the least, but violet gets bent the most. Now I have turned off the lights. Now all the colors are visible clearly. This is a double convex lens. So it has curvature 1 and curvature 2, and it even has medium. So this is like a rectangular glass slab. These two are prism. So in center the light doesn't bend. On side this is a prism and it is bending towards base. In prism it happens like that. So this converges lights. Its focal point is here. So now its focal point is here. 3 parallel beams have come. Now the lens has converged them. Curvature 1 is also helping and curvature 2 also. Here also slight bending has taken place. And here also bending has taken place. And change in medium also. Now I'll put a thinner lens. This has less curvature. So its focal point is far. It means that it is a weaker lens. The more the stronger, the nearer the focal point will be. It is a weak lens because its curvature is less. Now we will check with both the lens. Total power is more. So this is a double convex. Now I'll take with 1 curvature. This has 2. I'll change with 1. So you can see its focal point is far. Somewhere here. So both the curvatures are important to converge light. If it has two curvatures, then it will converge near. So there are 4 points to decide the focal point. Curvature 1 and curvature 2. These are the first ones. So the third and fourth point are first medium and second medium. If the difference is more, then there will be more bending. If it is vacuum here and here it is very dense material, like this is glass, so if diamond is there, then it will bend even more. Then this focal point will be very near. So you may be thinking that how to cancel the effect of this. This is converging. So do you think there is a diverging lens? Yes, there is. This is diverging lens. So it is cancelling the effect. Now we can even check like this. It is diverging all the rays. This has more curvature than this one. It is diverging more. If we use both of these, then they'll diverge even more. What decides the power of lens? There are 4 points: curvature 1, curvature 2, and medium 1 and medium 2. So if we'll remove curvature 1, then its power will deteriorate. Now its power has deteriorated. It has only one curvature 2. This has both the curvatures. So this is stronger and this is weaker. So this is a glass slab. In this we have put a ray of light like this. And now we'll observe what happens to the ray of light. We'll now turn on the lights to observe. So it is going zigzag and not even a little light is being drained. But the glass should be fully transparent so that it doesn't get absorbed. In fiber optics also this rule is used. Before there were wires, so there were amplifiers. So amplifiers need lot of maintenance. So this doesn't even need lot of maintenance, and this is a very cheap way.